Hey everybody, my name is Mehul, and I'm going to be doing a presentation about my experience in the computer science department at UC Berkeley. Um, so yeah, I'm a sophomore undergraduate. I'm undeclared right now, but I'm intended computer science at Berkeley. I should be able to declare by the end of this semester after I finish the last lower division requirement. Um, I'm a CS10 academic intern for this semester. I'll talk more about that later. I'm an IEEE activities officer. Also more on that later. When I was going to Hayward High School, I was the secretary of robotics club. That's back when Mr. Moore was still there. And I was a member of anime club and math club. And what happened with math club? That was back when Miss Bloomquist was here, and then she left, and the club kind of disbanded. And that's how I actually joined robotics club. So yeah, I was class of 2020. This was like during the live presentation I gave, but I did see quite a handful or diversity in who was interested. And so there are a lot of people were interested in majoring in computer science. Handful of people have taken APCSB. So I'll talk more about so what is computer science? So not all problems can be solved with computation. For example, many problems require interaction with humans that is less suitable for machines. Many folks focused on understanding or broadening the scope of what problems computation can solve. On the other hand, we're learning that many problems which we once thought machines couldn't solve are within reach. It now seems possible that a computer can read or even write an entire book. So how do we solve those problems using computers? So that's what the first kind of class of the lower division courses at the CS department is about, CS61A. I'll talk more on that later. So what techniques lead to effective solutions? So one of the coolest things about CS is that you can solve a problem in any number of ways, like sorting a list, for example. There's different ways to sort a list, but which one is efficient? That's what 61B is about, or data structures. Like there's different algorithms to sort a list. Some are like take more time compared to others. Some are more efficient. There's kind of trade-offs in yeah, runtime and like space complexity. Um, so there's a whole bunch of different like subparts of computer science. It's a very broad field. So we have like as a subcomponent of computer science, there's systems which are like operating systems. There's artificial intelligence, which is like getting computers to do what humans do. I'll talk a little bit about this later too. And graphics is like animation and films, so like Pixar. Security is like design security schemes that protects from data breaches, like the one that affected UC Berkeley last year, where kind of a lot of people's information got leaked. So we want to kind of have security to protect against those kinds of data breaches. Networking is like kind of like the internet. Programming languages is Java, Python, Scheme, SQL, like the different kind of languages we can use, or JavaScript. Um, so yeah, the last one's cut off with theory, which is kind of it's kind of like the math behind um, the programming that we do. And I mean, I'm currently taking a class called discrete math and probability, and that is kind of like a little heavy on the theory portion of computer science, but it's not really about programming. There's kind of more like upper division classes I haven't taken yet. That's on theory, so I can't really talk about that. But yeah, this is artificial intelligence. Like even that's still a broad field. So the components that kind of make up that are like computer vision, natural language processing, robotics, and the list kind of goes on. Um, so what kind of courses should you guys as high schoolers like take to Actually, let me take a water break. So as high schoolers, if you're interested in attending Berkeley or kind of interested in the major, it's a really good idea to kind of know this, which is that so we should be like, I know that algebra 2 is like the bare minimum for like a 4-year university or for like community college or but you should it's highly recommended to finish calculus 1 or like AP calculus AB with John Fraser. Like during your senior year you should be taking that. um I mean, what I did, like what some people have done is like they could take pre-calculus at like Chabot during the summer to kind of like catch up on that. Calculus 2, so I know that um there's only AP Calculus AB, which is the first semester, so we don't have VC in our school. But some people are like, sometimes some people take Calculus 2 the first semester, like the summer semester before they start like their official like college years, like maybe at Chabot also. And that would be a really good idea to just kind of like be ahead, or to kind of get like the lower division math classes out of the way. Because it, like if you take calculus 1 or calculus 2 in like UC Berkeley, for example, it's going to be a lot harder compared to just taking the AP class. Or so you can actually if you get a 3 or higher, at least for UC Berkeley and for AP Calculus AB, you can just skip Calculus 1 and go straight to Calculus 2. Calculus 2 is like where they start with integration by parts, they move on to trigonometric substitution. So they finish all the integration, and then they kind of move on to a different topic. Actually, I forgot what that was. Let me just check. Oh yeah, this is kind of just the syllabus, but you guys probably don't know what any of this is, but they go over like series, power series, Taylor series, um, differential equations, oh yeah, the second order differential equations, series solutions, root tests, ratio tests, like limit comparison tests, those kinds of things. But um, essentially, so if you're doing EECS, like electrical engineering, computer science, if you're interested in doing that, you'll need to take multivariable calculus, which is like calculus 3. But calculus 2 isn't really like essential for that, except for the integration techniques. So having a strong like calculus foundation is like pretty important. If you're gonna like, if you're in EECS for computer science, it's not super important, I would say. Um, yeah, unless you're thinking of doing data science. I'll talk more about data science later. But yeah, too much math talk. Um, so for English, if you get a score of 4 or higher in the AP English language, you can skip a whole English class. For CS, at least for EECS, they might have their own rules. I'm not too sure. You could look it up on the website. Um, if you get a 5 or higher on the English literature, or just 5, sorry, yeah, 5 on the English literature, you skip 2 whole English classes. But if you get a 4 on English literature, you only skip 1 class. A 3 would get you out of the entry level writing requirement, but you'll still have to take the 2 classes. And unfortunately, that's what's happened to me. I had to still take 2 classes, but I'm done with them. So that's out of the way. No more English for me. And I can just focus on like my major classes. So AP Computer Science Principles, it doesn't really allow you, like UC Berkeley classes are pretty rigorous. AP CSP is kind of just maybe the first 1 or 2 weeks of like 60 CS61A, the first class. It barely covers anything, and it's not that much coding, I believe, from what I remember. I took it with Mr. Lockie, but during the pandemic semester, so we didn't really learn as much. Um, but he can give you elective credits, but that's it. You'll still have to, it wouldn't help except for that, just having elective credits. AP statistics isn't that helpful for computer science, but I guess knowing that can be useful for data science. But it's not really required. I guess it's, if you're trying to do data science, then you should probably take AP Statistics. So yeah, just the classes that I've taken like in terms of CS so far. Um, so I actually did start out with AP Computer Science Principles with Mr. Lockie during my last like senior year of high school. So at first I didn't really like CS. I heard this like on Reddit, like, oh, this is like the easiest AP class. Um, the pass rate is really high. I think it was like 70, over 70%. So I know like when I took it with Lockie, we didn't really learn Python. We mainly it was a pandemic semester, so I don't blame Lockie, but we we use Scratch, which is like the block-based programming language, and kind of worked with pseudocode. I mean, yeah, pseudocode is like a big part of the class. Like on exams, it's like pseudocode. It's not like real code. Um, so um, so we had a in my year we only had to do the create task and explore task. We didn't have a multiple choice. So I kind of got the easy route on that, and I got a 5 on the exam. I mean, yeah, I guess the score didn't really matter because as long as I got a 3 or higher, I would get credit, like the same amount of credits. And yeah, your score on the exams, like nobody really brags about, oh, I got a 5 on the APCS because like APCSP is really easy. Yeah, nobody really brags about it when they like get to Berkeley because at Berkeley, like everybody's done like something insane. Um, but I guess I can play this since this is my video. Um, so yeah, this was in Scratch, and the bottom is kind of the cards I had, like the player, and that's a score of 20, and the dealer had a score of 19. This is kind of like a little other mini game I have, which is like bet high or low. Oh yeah, we can bet chips too. Looks like I had this is my current bet, and these are like the chips that I have currently. Um, yeah. I mean, yeah, I guess what I don't really like that much about Scratch is like it's kind of laggy, as you can see. Yeah, so I think you guys get the idea. It was just really fun. I was pretty into it. I spent a couple weeks on this, but I mean, it doesn't take a couple weeks, but that's just because I was like pretty new into like programming. This was kind of like the first like big project I did. So I'm pretty grateful for that experience. And then oh, it's like a sign dropped in the room I'm in. But when I applied at Berkeley, I applied as molecular and cellular biology, mainly because like kind of my parents were pushing me into that route. But then after like a semester, I took chemistry. I realized I didn't really like doing this. I didn't want to go into medical field anymore. And so I tried taking the first like core class, um, which was the structure and interpretation of computer programs, or CS61A. But I really like they kind of expect you to kind of already have prior programming experience, which I kind of didn't really have because I only use Scratch. So they go really fast, like it's really rigorous, and the exams are like brutal. So I tried taking that class in my spring semester of my freshman year, but I ended up dropping that class, and I decided to take CS10, which is the Introduction to Computer Science for non-majors. Um, so that's what happened. Oh yeah. Yeah, just follow up on that blackjack kind of, or the poker project. Yeah, oh, see, this is blackjack. Yeah. So I also re-implemented blackjack on my Discord bot. A lot of object-oriented programming involved. So there's like a card class, a deck class, player class, and oh, it looks like my bot won. But yeah. Um, okay, so these are like the lower division like classes that we have to take as CS majors. For EECS, like there's like a couple more classes too, like calculus 3, like the physics kind of classes. I'm not too sure exactly, but I do know like from my friend, that's what he was telling me. So 2 semesters of calculus, Calculus 1 is just like the AP calculus like at our school. Calculus 2 is like the I explained earlier, like like more integration. Um, we have like Taylor series, power series, differential equations, that kind of stuff. Um, so this class, E16A, is all about circuits, and it's also linear algebra. So usually people take this class like after they finished like calculus 2, or like you should kind of know how to do. I mean, it's not really needed, but yeah. This is more on linear algebra, but mostly more about circuits. Um, I'm currently taking 16A, so I can't really talk. Um, it's not really worth talking about these two classes. But the main three classes that we have to take as CS majors to declare is CS61A, CS61B, and CS70. This machine structures is kind of about like, I guess, memory. Using like the C programming language. I'm going to take that next semester, so I'm not going to talk about it in this presentation. Um, so yeah, we have to take these three core classes to declare, and the GPA is kind of how it works here at Berkeley is a little different compared to what we're used to in high school. So the pluses and minuses, they actually matter. So a D minus is a 0.3, like a straight up D is 0.7, D plus is 1.3. So essentially we need to have a 3.3 average in these three core classes. So a combination of that could be, I got an A in 61A, I got a B in 61B. So I think that means I need is that right? I need an A in CS70 to then declare, because the average of that is a 3.3, I believe. 4 plus 4 is 8, plus 3, 11. 11 divided by 3. What is that? Let me just check real quick. Okay, well, okay, so okay, well, you can kind of compute the computation, but what I got is an A minus in 61A, an A in 61B. So I only need a C plus in CS70. So like, you know, it's really hard because like everybody here is smart. So like getting an A in high school was kind of like me just I could just sleep through like math, and I can just do the homeworks, and I can easily get like the A by doing the homeworks. Um, and it's just like computational. But here it's like math kind of gets a bit more abstract. You'll have to start doing proofs, theory. So and some questions you might have to entirely skip a question, and sometimes that's perfectly okay because the class might be curved. So um yeah, it's like you feel bad about skipping an entire question, but that's kind of that's pretty common in like math exams. For CS, not so. I mean, for CS70, yeah, because it's a math class, but 61A and 61B, not so much. You should okay, I'm rambling too much, but CS10 is the first like, or it's a class for non-majors. So it's just introduction, um, an introduction class. There's a lot of reading involved. Actually not that much. It's like a couple of articles. So half of the course is in Snap. Like it's a block-based programming language kind of based off of Scratch, but it's kind of Berkeley's kind of implementation. It's a little bit different. Like you can kind of create fun. I'm not sure if Scratch allows you to create like custom functions, but we do that a lot in Snap. So in the other half of the course is in Python. So you kind of translate what you learn from Snap into Python easily. So Snap is a little bit more involved. There's also kind of like their own version of list comprehensions, and there's like recursion, and there's a lot of stuff in Snap. It's not. I feel like it was a bit challenging when I took the course. It definitely wasn't the easiest thing, but compared to 601A, it was pretty easy. So there are projects in this class which aren't that bad because it's just an intro like for non-majors. So for example, Mastermind is like we're given like a 4-digit, like player one inputs the secret 4-digit like password, and then player two tries to guess this 4-digit password, And the script right here kind of like lets player two know which slots out of the four were correct and which slots were incorrect. That's Mastermind. 2048 is like the board game with the 4x4 grid. Um, but it's like you can search up the rules, but it was a lot of for loops. It was mainly so I had to just create the logic of the game, not like the graphics. So it's like whenever you make a move or when you start a game, there's like a 2 or 4 that like randomly spawns on the board. Like a 2 has like a 75% chance of spawning, and a 4 has a 25% chance of spawning in a random empty tile. And there was like rotate the board like clockwise, merge like the when you go up, down, left, right, you'll have to like merge all the pieces up or down, left, right, um, and check if there's no moves left, which kind of means like there's a game over. Um, so no moves left is like it checks after every move that you've made, like it kind of tries to make a move, and if there's no moves that are like able to be played, like if the board stays the same after trying to make a move, then we'll reach their game over position and like all the tiles are full. Um, yeah, and I guess during my Thanksgiving break of last year, I decided to just code this up again in Python using the Pygame kind of library. That's my GitHub too, if you want to just check it out. Um, but fun fact is that coding up 2048 used to be a project zero for CS61B, which is the data structures class. But fortunately, they got rid of that. It's mainly because the professor I have, he likes to kind of change things up and kind of make his own kind of board game. So I also made like the last project that we do. Oh yeah, I had Pytris. We did like Pytris, which was like Tetris, but I guess I couldn't really find the file for that. Um, yeah, but we made like a Tetris version in CS10 in Python, but it wasn't too advanced. That was the only I think Python project that we did in that class. And the final project could be in either Snap or Python, but so I decided to do with a group of 2 other people. Um, we decided to make Snake in Snap. It's like you have like a snake that tries to eat an apple every time like it eats an apple, like its tail kind of grows, and if it run like the snake runs into itself, then game over. Um, I think this was the main script with like a lot of helper functions. I think this is one of the main scripts. I think there's more than one script on the. So right now I'm actually a CS10 academic intern. So I help out during labs 2 hours a week, and there's like 1 hour meetings. So I go through the labs and I like I kind of just make sure that I know the content and I can like successfully help out the students. I think it's pretty easy. It's like low level, low pressure kind of thing. If you don't know some like an answer to a question, you can just try to ask somebody else or ask the teacher assistant for help. So you don't have to know everything, but you should be confident with the material. So 61A, this is the first course for like the major. Like there are a lot of people that are like even not CS, like they say like this is like a must take if you go to Berkeley, like take CS61A, but I don't know about that because this one kind of assumes a lot of like programming knowledge before you take the course, equivalent to like taking APCSA kind of like level of familiarity with coding. So 61A is all about managing complexity. So that kind of can look like abstraction, helper functions, variables, yeah, abstraction, programming paradigms. So like it's like classes. So it's an intro to programming, which is kind of a lie because they do expect you to know. They go really fast. So I mean that's just what it says on paper, but I would say not really. They go through like 3 different languages. So they go through over like a full understanding of Python fundamentals, but more on that later. I think I had like a list of topics, and there's 4 large projects to kind of get you to master the material, and you kind of understand after taking this class, like how do computers interpret code? And that's where kind of the environment diagrams they come in. So just how do like computers store like the variables um, inside of the like different frames. So yeah, structure interpretation of computer programs. It's an intro course. It teaches Python, Scheme, and SQL as the three programming languages, and they do go over regex, and they're trying to go over, I think it's called BNF. BNF, I don't even know what that is, but regex is, I don't really want to talk about regex, but um, so exam like this class is known for its insane exams, like because the reality is that a lot like CS computer science at Berkeley is a very impacted major. Like they need a 3.3 GPA requirement to kind of get students to lose interest, and they're trying to say this is really in demand, and um, they make the exams difficult so people like kind of lose interest in the major, and they they want the top students basically. Um, so in Python, this is also like the logo of the like the class. Like this is like the lambda symbol. Um, and so we go over all these topics. I won't name them all, but scheme we go over I think about 2 weeks of scheme. And we do build a scheme interpreter as like the final project. SQL is 1 week or maybe like two lectures on it. Um, yeah, and this is actually the website of the class. It's publicly available. Anybody can like kind of go over the discussions, the homeworks, the labs, and actually do you guys can do them yourselves. And there's an autograder, and you can actually run your code against the autograder, and you can like literally do the assignments like right now if you wanted to. And some of the solutions are even available too. So it's just publicly available. All the resources are available. You don't have to be a student to have like do the assignments. So just kind of logistics. There's a weekly lab section. I mean, when I took this during the summer of my entering my sophomore year. So that's because I decided to change majors, as I said, a little bit late, like later on in my kind of career at Berkeley. So summer this wasn't exactly it for the summer, like because so I took the class, there's about 150 people, but usually there's like over 1,000. But summer it's like people aren't really using the resources, and so like the lab sections kind of just turn into office hours, and I don't know. But right now there's like a weekly lab. Homework assignments take at least 3 hours, I would say, unless um maybe the first couple of weeks it might not take 3 hours, but then it kind of picks up and you'll get into topics that you haven't like seen before. Like most people haven't seen linked lists, so when they kind of come in, or like iterators, generators, trees, most people don't haven't seen that before, like coming into Berkeley. And so when we get to that, then that's like when people start losing their disadvantage of like prior program experience after maybe you want the start of week 3 or 4 or something, or after the first midterm. There's discussion sections, which it's kind of like a small group of people where you kind of go over a worksheet with like problems to just discuss the material with like a undergraduate like student instructor, um, or TA, like teacher assistant. There's only virtual office hours, I believe, because um, we're getting there's like a funding crisis, so we're losing the support for in-person office hours. More on the funding crisis later. And there's also a video on that, the funding crisis. So for like all assignments except for exams, we can like submit our code to the autograder, and we automatically know like when we're correct, like before like the deadline hits. It's not like an English essay where we have to wait for the teacher to grade it, and it's like there's an English essay, there's like multiple answers, there's multiple ways, but like for an autograder, like they run a bunch of test cases on your code, on your like function, and if you pass all the test cases, you get all the points. It's kind of like that. um so this is just people kind of like complaining on Reddit, like 61A exams are really difficult. Like I mean, compared to like the like exams I took in high school, like this one, it's kind of like actually like in like once like they sometimes say that like 61A exams like they compare with an IQ test. I mean, it's a lot of pattern matching. It's a lot of like critical thinking, and sometimes you're just trying to read what the professor is like trying to do, like trying to read the professor's brain, or what are they trying to make you think. And yeah, I guess variable names are like kind of hints as to what you're supposed to do. But let's see. Yeah, like you can have perfect scores on labs, homeworks, and projects, but it's still recommended to like grind out at least like 10 practice exams before like your actual exam. That's what I actually did during my summer semester. I got an A minus. I was like 2 points away from an A, but that's okay. But you really have to grind to get the grade that you want. Um, and that's because CS is an impacted major. Um, it was one of the top schools in the country, and we're not going to get that kind of rank unless like the exams are going to be really difficult. Like that's how we need to like prove that we're like the number one by kind of making exams difficult, I would say. And so yeah, the exams are harder to just limit the number of people that are interested in CS. Otherwise, we're gonna have like the whole school trying to major in CS if that wasn't the case. Um, at least 20 hours per week. I actually spent more than that, but that was because it was during the summer. But grind out practice exams, build intuition. Yeah. So Scheme is about so in Python, it's an object-oriented programming language. So on the other hand, Scheme is a functional programming language. So it's kind of designed on like math functions. I'm using like conditional expressions and recursion. So there's actually no loops in Scheme. And a fun fact on Scheme is like the whole course, 61A used to be fully taught in Scheme in 20 like before 2011. But now like we're realizing the industry, like nobody uses Scheme in the industry. So people are complaining about that, and eventually they moved on to Python, but they still have a portion on Scheme. 61A, they kind of go through like three different languages, like, but so this is like a comparison. This is like the GCD function, the greatest common denominator between like two numbers. So the top portion is Scheme. So the main like takeaway from this is just like in terms of syntax, how it's different. And this is also a recursive function. So kind of everything that we do, almost everything we do in Scheme would be like kind of be done recursively. Um, but yeah, let's see. So the GCD of 35 and 5 is 5, right? The GCD of like kind of any prime number with a non-prime number would be 1. That's a fun fact. Um, yeah, I'm not gonna get too much into this, but like just see like how it's syntactically different. And this is kind of a language where we use a lot of parentheses, and it's easy to get lost as to like you might have like a syntax error because like you don't have the same number of parentheses or something. I hated that. So SQL is like it's like a declarative programming language. So it's you don't have to, I guess Python, like you have to like you have a lot of variables happening. But in SQL, you don't we have that kind of going on. You're working with tables mainly. So you can like query a table for like a bunch of rows that you want with like the select statement. So you literally just say what you want, and that's what happens. So like these are like the keywords: select, create, insert, update, delete. You kind of do these kinds of things in like one line, and you kind of like get a result or do some or manipulate a table somehow. That's what SQL is mainly about, like working with the database. um, yeah. So this is one example of like a query that we would use. So the language right here is like, this is like SQL kind of thing happening here. So we're saying select, the asterisk is everything from the table called public.dict, which is this is actually using my bot, which is kind of like the user defined dictionary. So this returns all the rows, like the whole table of like all words, like all with all the columns and the rows. Um, yeah. And what is this? Oh, this is so this is just another like example of of a usage of SQL with a different table, which is this is my users table where I kind of store like everything. But now I'm saying select these three columns from the table users. So the three columns are ID, which is like the Discord ID of like a user. Usage is like the number of commands that person has used, like just ever forever. And Gald is kind of like my money or currency system. So we're selecting these three columns from users, and where is kind of like a filter. Like we're saying we only want the to return the rows where Gald, like this Gald is greater than or equal to 400. Um, so we only have 9. I believe there's only 9 different people that have used my bot that have gotten that much. Um, and we're saying order by usage, descending order. So that means the first row is going to have the most like amount of like usage, and the last row is going to have the least amount of usage. So, all of these are kind of optional, but um, just example as to like how SQL is kind of used, like a brief like kind of demo on that. And there's also like the update, I guess like kind of keyword. Um, uh, okay, so if you want to update the amount of gal that a person has, we would use this kind of thing. So update the table users, set gald equal to 1. Like this is kind of just a placeholder, equal to however many galds. Like let's say like a person has just finished like a person has finished, like they played a game, like a poker game, and they got like 2 pairs, so maybe they get 20 experience points for that. So we would say set gald equal to gald plus 20, or ID equals the Discord member of that person that played the game, which was like would go in the number 2 right here. And that would like that's how we would award them experience points and reflect that in our database essentially. So data structures, CS61B, which is the second course in the computer science lower division requirements. So whereas like we did Python, Scheme, SQL, and 61A, 61B is all in Java. So we use IntelliJ. 61A, you can kind of use whatever, like Visual Studio Code or whatever you kind of want. Visual Studio Code is like the main one. Atom. Yeah, so exams are kind of more similar to lecture content, whereas like 61A is kind of like puzzle, like it's like a puzzle solving kind of thing, or it feels more like an IQ test. But 61B, it's a little bit more clear as to what they're asking, and you're kind of less confused, and they're not as mean. But projects are worth more for your grade. Exams are kind of less stressed because they're worth less. There's no project partners. In 61A, there was like one project partner. But students can still share ideas, be collaborative, but don't blatantly share your code. Man, I have like a lot of like toxic, I had a lot of toxic friends in the study group I was in. And dang, it was pretty bad. Um, People were like harassing each other for code, and led to kind of like people ghosting each other, or just like it was really bad. Be careful about who you make friends with, and don't be too needy. As but let's see, we have yeah, these are like the topics. We kind of like the first couple of weeks are kind of just introducing the Java like programming language. So we go over like the basic data structures like arrays, linked lists, and then we get into like more advanced stuff like asymptotic analysis, like what is the runtime of like the is palindrome function or the factorial function. Um, then we go over like trees, hashing, game trees, and so on. But this class is really important for interviews. Like wherever college you take this, there's going to be some kind of data structures class. And this is the most important class that you're going to take for interviews. It's really important for lead code. Lead code goes over a lot of these topics on the bottom right here. Yeah, so um, you really want to like pay attention to this class and do well in this class. And there's 4 main projects. but yeah, like Python and Java, it's like once you learn one programming language, I mean, don't, um, okay, aside from like Scheme and SQL, like once you learn one programming language, it's easy to kind of transfer over to like to another one. It's easy to learn. Like once I learned Python, like Java wasn't that. Java was kind of a bit more verbose as to like you have to be more specific. Like this is a public class, so it can be accessed from like somewhere else in another file. um and like Java, you have to say like this is an integer, this variable balance is an integer, but Python, they don't really care. Like once you assign like balance to 0, you can set it to a string later if you want, but in Java you can't really do that. I mean, you can't, like, I guess there's just, you can call this an object, but essentially you can't really do that. You have, yeah, Java is a bit more strict on its rules, and like it compile, like if you had like an error somewhere in like the deposit like function right here in Python, you wouldn't realize that you had an error until you like run the deposit function. But in Java, like Java like kind of compiles the code and checks for those kinds of errors. So it would stop you right there. Um, but yeah, similarities, it's very similar as you can see. And this is kind of like just abstracting a lot of this stuff away. Really similar kind of things that we're dealing with. So Flood is like the first like project, kind of a board game that kind of just introduces students to the Java programming language. So there is skeleton code provided for this. But you guys can check out if you're interested in this. It's not the best board game. I would rather do something like 2048, but Flood is a lot of recursion, I remember, and some for loops involved. Um, oh yeah, this is kind of how the game looks like. This was one of the functions I made. Um, but yeah, I don't want to go too into this. It's really not that cool. Enigma, I don't like Enigma. Enigma was the like the most stressful project. I was in the Soda Hall labs like for super long, like in the project party office hours for this, and it's a debugging nightmare. Like we were trying to, it's like a war, like Enigma is basically like a war machine that we, like the Germans used during World War II to encrypt like military communications. So we had to, there was like a bunch of rotors, and we had like a setting, and with that setting that the rotor, like the rotors are on, like, and we input like a string, it returns us the encrypted message, and with the same settings that are used, it can return us the encrypted message, or decrypted encrypted, yeah. Yeah, it uses a lot of data structures, like hash maps, array lists. I think those are like kind of the main kind of things that we used. A lot of regex involved in this too. And it was like you needed to have, there was like a lot of different like classes that we had for this, like moving rotor, fixed rotor, permutations, alphabet class. I remember, yeah, working with strings, but um, you had to kind of write your own tests, and you couldn't really rely on the autograde anymore. But essentially, like the way they kind of graded this is like it was almost like all or nothing. Like you need to have like all the classes working, and then most of your like kind of code is like from the main class. And if your main class wasn't working at all, then you kind of like the main, like you could probably only get 5 out of 26 if you didn't have your main class working. Um, that was terrible. So Jumping Cube is kind of the AI project. So we make an AI that would like make moves in a board game, which sounds kind of complicated, but it was mainly just like kind of transcribing pseudocode that was used during lecture into like working with the game. You guys can look at this at your own time, like try to look at the game. It's not the best game, but we also made a graphical user interface for extra credit. So that's what the GUI looks like right there, and that's what the game looks like. It's a lot of recursion. I remember, yeah, I remember a lot of people just kind of being stuck with this like infinitely recursing kind of blocks. And I mean, honestly, like this was probably like the project where it just kind of like clicked as to what was happening. And this project is about like runtime too. It's like the AI has less than 15 seconds to like make a move. So this kind of board, like an n by n board, we would think we want to use like like an array of arrays, right? Like a 2D board. But this is actually implemented in a 1D board. So it's pretty insane. But that's because if we're trying to like look at all the possible moves that the AI can make, we that'd be like n squared time because a 2D board, like quadratic time, when we could actually like get away with doing it in linear time. So runtime is especially important in these kinds of programs. Especially like if like you're waiting for an AI to make a move, um, then we wouldn't want to like a random person playing our game wouldn't want to be waiting like 20 seconds for this AI to respond. Like they expect maybe a couple like they would expect as much time as like a human would take. I mean, it actually AI would actually like take less time. On average, though, like a couple of seconds to like just realize what move they make, and that move is like the most optimal move, essentially. So like the kind of algorithm that most of these games use, like it's used in chess, Connect Four, tic-tac-toe. Tic-tac-toe is not that like it's it's pretty simple, but something like chess, they're gonna use the minimax algorithm. And so the minimax algorithm essentially, I would explain it using tic-tac-toe. Like, okay, how does AI know what move to make? Well, I'm not the best at explaining this, but we start out, this is like a game tree essentially. And so the top, so we have, okay, X has made 3 moves, O has made 3 moves. And so the next player that's going to go next is X. So the AI, okay, AI is O. And now we're going to brute force all the possible moves that can possibly be made, and we're saying, okay, what if X makes a moves here? Okay, let's go down. And now, oh, wait, who is being maximized here? Sorry. Okay, so we're trying to favor X. So I guess X is kind of the AI here, I believe. I'm not too sure. Yeah, I believe so. So, what move did they end up making? I'm not too. Oh, it didn't. Okay, so sorry, guys, but um, yeah. So think the I think X is like the AI right now or the opponent, and so we're gonna brute force all the possible moves that can be made. So let's say X makes a move here, and then with this in mind, let's say O makes a move here, and so we're gonna return like we're gonna evaluate like this board right here. Like we're gonna assign this board like a score, and we're gonna say that the score is -1. Why is it -1? It's favoring the opponent, and we don't want O to win. We want to favor X. We want X to win, and so if X makes a move here and O makes a move here, like we don't want that to happen, right? Tic-tac-toe 3 in a row. And so there's some alphabetic pruning stuff happening. I don't want to go into that too much, but let's say brute force all the possible moves. There's 2 moves that can be made. There's like 2 like new free spots. And so let's say O makes a move here. With that in mind, it's like X has to make a move here, and that would X would win. And so evaluating the position, like all the like positions or like moves on this board, we see that X wins. So that's why we're returning +1. But overall, we're returning -1 right here because like we know there was a way for O to win. So I guess in alphabetic pruning, if we see there's a way for O to win, we can prune, we can just cut off this entire like branch, and we wouldn't actually have to like look at the rest of the moves. Like we wouldn't have to look at what if O makes a move here, because there was a way for O to win, and therefore like using alphabetic pruning, we don't have to check the rest of this tree, and that would kind of save us on runtime. But yeah, we would still have to check the next kind of right here. What if X makes a move here? And similar kind of process here. I believe it's saying 0, right? I think this is 0. Like, yeah, because nobody's won yet. That's why it's saying 0. So -1 is like when O wins, and 1 is when X wins. And so right here, going down the tree. So like the depth of the tree is 3. That's like one of the arguments in the minimax kind of algorithm. If the depth is Like that's just how many kind of layers we have in our game tree. Um, yeah, so okay, 0 is also like a draw. So this was a draw, and the draw is still favored over like O winning. So um if there was like no way for X to win, we would favor a draw over like the opponent winning essentially. And that's what commonly happens. Um, so I guess we could also like cut this branch off. Um, I'm not too sure if that was necessary because it looks like it just returned. Yeah, it returned 0. Yeah, I think overall what would actually happen is like this move would be played. Because this move right here, -1, is not favored. So what is gonna most likely end up happening is that the AI X is gonna make a move here. Um, because that's like well, yeah, let me get back to that in a second. But say X makes a move here, then one move that O could make is right here, and that would end up in a draw. But if like X makes a move here, there's a way for O to win with a tic-tac-toe 3 in a row, and that's why we're returning -1, which is okay. So I guess this one couldn't really be pruned. So we would do it. We would still have to check this part of the game tree. um, but if we have -1, that means there is a way for us to lose. And that's why we're not gonna pick this move. We want to pick that move that like with the highest kind of like value. That would either like favor X to win or that it would favor a draw. And so that's why the AI is actually gonna pick this move right here to make right here because there's no way for O to win. Like just brute force doing all the moves behind the scenes. This is how kind of like the like an AI works. And yeah, because there is like a 50-50 chance. I mean, not really 50-50 because that's not really like how real life works, but there's a slight chance that that X wins. That's why we're favoring this kind of move. And it's either win or draw, basically. So yeah, the AI makes a move that maximizes their score. So it evaluates all the legal moves and it gives a value for picking that move. So as you can see right here, like the value of like this, like making this move is -1. Um, the value of this move is 0. This is -1. Um, yeah, and overall, what's being returned is like this kind of position of the board is like kind of worth 0 points. Because I guess there's kind of yeah. I mean, there's a way for it to win, but that's most likely not going to happen because what we're doing is um, we're assuming that at like O, like the opponent that might like be a human or not, they're always going to make the most optimal moves. And we're working under that assumption. And yeah, so AI, like this minimax algorithm is like a recursive algorithm right here. Um, I guess you can't really see it, but yeah, it has its recursion and the static eval kind of thing in terms of tic-tac-toe. It kind of like the base case, like when death equals 0 right here, like when we're at the bottom of our game tree, or when we see that we have a game over position, like there's no more moves left. That's when we like kind of assign like a value to like this making this move, and I guess this is worth +1. And so going back up to the recursive stack or the recursive calls, this is worth +1. Going back up, this is worth -1 because there's using alpha beta pruning or yeah, it's a little bit kind of in depth, but so when we do minimax, we have to kind of like this kind of relies on having a good heuristic value. And so the heuristic value in this case is like -1, 0, or 1, which is like -1 is the opponent wins, 0 is a draw, and 1 is like X wins. But in more complicated games like chess or Connect 4, it's a little bit more complicated as to what the heuristic value is going to be. Um, yeah. So for example, I guess I made a Connect 4 game, I think during like Christmas break or something. Um, this is pretty complicated. Uses the Minimax algorithm. I made an AI to play the game. So there's single player, which uses the AI. There's multiplayer, which is just two-player, doesn't use any AI. And you can also have two AIs play against each other, which is pretty insane, but it's also kind of deterministic. Like they'll always make the same moves because of the heuristic values, unless you add like an element of randomness if you want to do that. Uh, but yeah, this is in Python. I made it in Python. Oh yeah, this is the recursive call right here, and this is the base case right here. Um, that's my GitHub if you want to see my Connect 4 how I did it. If you're interested in how the Minimax algorithm works, there's a lot of resources for that. So there's also the Expectimax algorithm, which is kind of it's like the Minimax algorithm, except Minimax kind of involves like it's in games where there's like no elements of like chance involved. So chess, there's no element of chance. It's like deterministic. Um, and like Connect 4, it's deterministic. But in games like 2048 or Pac-Man, we have like in 2048, a random 2 or 4 can kind of just spawn in. But like we can see like the computer, like essentially this guy, what he did is he made a computer that just like makes a bunch of moves in the game and makes the most optimal moves using like the expected max algorithm. And he's able to get a really high score right here. And we see that it takes kind of more time, as like sometimes it takes more time, sometimes it takes like less time to like for the AI to figure out what move they want to make. Well, that's because I guess they might be using kind of alpha pruning. It's like we might be able to just skip a bunch of moves, like a bunch of we can kind of just prune like our game tree at certain points in the game, realizing that like they're not worth evaluating or checking. It's a bit complicated to like kind of explain right now. Um, but you can take a look at that if you're interested. Um, Bear Maps is actually a project by the other professor that teaches this course. I didn't do Bear Maps, but it's like using graph data structures and algorithms. Yeah, I think this is like a map for UC Berkeley, the north side. Oh no, Gourmet Ghetto, is that on the south side? I'm not too sure. Uh, oh, this is actually the street I live on. Okay. Build your own world. So this I didn't do this project, but you kind of make a 2D world like Zelda or like Pokemon, like the old games, kind of like that. Uh, with like world exploration. So this one had like no starter code, and the world has to be pseudo randomly generated, and you should be able to like control an avatar. I can't show this video because of copyright, but this video is like a person at Berkeley a couple years ago. They made like a kind of like a Pokemon game. It's kind of like it's not that serious, but I found it pretty funny, like in terms of like meme content. Um, so this class is known for Gilead as being the most stressful project and the most notorious project of like the lower divisions. Like, um, yeah, everybody in CS, they know about Gilead. They struggle through Gilead. They remember it being hard. They remember pulling all-nighters a couple days before it was due, and they remember just working so long on it, but realizing that their design wasn't that good. And so this was like the first project where, like that computer science people here, like they start with literally no starter code, and they have to, and we're giving like not that much guidance. Like we have to make a design document as to like how we're going to implement. So Gitlab is essentially like if you guys use Git like to upload stuff to GitHub, it's like that. So we implement like the popular commands like git init, git add, git remove, commit, push, pull, branch, checkout. Checkout was like actually merge was like the hardest one. The merge was like my god. But we use like a lot of data structures like the tree map, hash map. We had to use I guess the commit objects kind of looked like they were like a directed acyclic graph. And we had to like have a SHA-1 ID. We had like a lot of point, I don't know, but Gitlet, yeah, we had to make a design document. But we had to like keep changing our document because we realized that some of our approaches wouldn't work out right, or we weren't as detailed enough. Um, but this is also where a lot of, I guess it's hmm, like you really have to start early on these types of projects. You can't just do these kinds of projects the last minute. It doesn't work out like that. Like this one, you got to start when it's released, and you got to be on top of it, and you got to know what you're doing. Like you can't just run your code against the autograder. Like that's not how it's gonna work for Gitlet. Um, yeah, like you really collaborate with people and just work, I guess, work with other people to like realize that your understanding is correct. There's a lot of like support in general, like there's tutoring. I guess tutoring, they're technically not supposed to help, but I got lucky and my tutor kind of helped with the project. But there's like project party office hours. I mean, I guess like their resources aren't that the best over here because there's like so many students. I think I took this class, there's 800 students, and like they like you can only spend like at least like the most is like 10 minutes with the TA to kind of just explain. um and they're not the best at debugging help either. Like you're kind of mostly you're on your own for debugging help, so that's really a pain. But and a lot of people, they kind of get like needy, or they try to like copy your code, and you got to be really careful because every now and then they catch students like kind of plagiarizing like code or stealing, like, so you got to be really careful about this kind of stuff. um but yeah, a lot of people on Reddit, they kind of like vents, like they spend tons of hours but they're not making progress, especially during the COVID semester because everybody was like alone. But I'm glad I took it last semester where we got back in person. Otherwise this would have been like an impossible task. And yeah, but yeah, Gillet's notorious. A lot of projects about, sorry, a lot of like stories about this over the years. Um, but I think I have a slide I skipped. I want to kind of show that. Um, these are kind of like the commits, and these are like the files being stored, and like each commit, and like the changes being made. And so we have like the date, we have like the version of the commit, the blobs or like the files of each commit object. There's like different branches right here. Like this is the like branch called branch. This is the master branch. So um yeah, yeah, you guys can look at that in your own time. It might be a little bit too much, but I'm just trying to give like a gentle like intro to this. Discrete math and probability, which is CS70. I'm not, we're going to talk about this too much, but I'm currently taking this class that's like math heavy. It's a class where like, okay, calculus one, you can just get away with like, you know, um, it's kind of formulaic, like the derivative of tangent is just secant squared. Like just memorize that and you're all good. Or just apply, you just know how to integrate this. Just remember these rules and formulas. Um, but in discrete math, you kind of have to think more abstractly or like more theoretical about things. Um, you have to prove things. So it's a curved class. So you actually do like the other two classes, 621A and 621B, they're like binned. So binned is like if you get this many points, you're guaranteed this grade, and you'll absolutely get this like grade. But in CS70, it's a curved class. So I guess like there's like two or one midterm and one final. So if you get the mean, like the average grade, like then you're kind of around like a B or a B plus. If you get like one standard deviation above the mean, you're kind of like A minus A range. If you get one standard deviation below the mean, and you're like C plus B minus range. So this is where like it's not a coding class at all. It's purely like math. I mean, I guess they did go over like there's certain programs where like it's impossible to like it's impossible to code up a program that shows whether like this program halts or not. Um, I guess we did go over like a little bit of pseudocode, but like 90, like 5% of this is just like straight up math. Um, so the first half of the class, it's like mainly about proofs, and the second half is like about probability. So this one is offered by like the EECS department, whereas like the math department does have like discrete math only, like a class just on discrete math. But this one is about like discrete math and probability, and they talk more about like what we should know, like I guess like RSA, error correcting codes, polynomials. Yeah, it's like a lot of like critical thinking is involved in this class. Modular arithmetic. Yeah, I think yeah, and this is actually publicly available too on this website if you want to like take a look at like what kind of like college math looks like. But yeah, students, they have to write proofs for the kind of the first time. So before you take this class, it's recommended you kind of complete all the you should be done with all the lower division kind of class. I mean, I these are not that essential, but calculus 1 and 2 you should like kind of complete before you take this, um, which is kind of doable. So clubs I'm involved with, I'm in a computer science undergraduate association. So like we host like tech talks, hackathons, info sessions, workshops. There was a social event like last Thursday I was in. They had a couple alumni coming back, like 3 alumni, just talking about their experiences, what they're doing like right now in the industry, like software engineering roles, and just talking about their experiences. Yeah, I'm also in IEEE. I recently joined this club. Um, and so they host like info sessions, resume workshops, kind of the same kind of things. Um, but they also host like they call them decals, which are kind of classes taught by like UC Berkeley students. These are like pass, no pass. So you're not getting a grade for them, but you're getting like units, like kind of to achieve like a unit cap. Because you need to take about for letters and science, you need to take 13 units per semester. So like technical classes are about 4 units. And so if you're taking 3 technical classes or like a 2 technical classes and like a breath class, you still need maybe 1 or 2 units to like get the minimum of 13 units. And so that's why people would take decals, like either like they need the units or they're kind of interested in the subject and they want like a maybe a fun class that they're not graded with. Um, so I actually don't know much about these decals, but I can say like I've taken like a Pokemon decal. They have like a class about Pokemon. Um, like they kind of just go over a general overview. So there's like a week about the anime, then the manga, then like Pokemon Showdown, competitive battling, then like the generations 1 through 8, that kind of stuff. But in terms of what this club offers, I guess I don't know what PCB design is, but kind of about circuits. Yeah, micro mouse, robotics kind of thing. But I guess what I do in the club is I'm an activities officer. So what that means is like I plan social events like next Friday, or I guess the Friday that we're coming back from spring break. We're gonna have a karaoke night. And I guess I'm gonna be in charge of that. I don't know. It's gonna be at Jaguar karaoke. That's what it's called. And in 2 weeks from now, we're gonna have a Super Smash Bros. Tournament, and I'm pretty excited about that. Um, and they're like a game board night, so maybe some chess, and hopefully we'll bring some pizza, and it's gonna be a fun time. Hopefully, a lot of people show up, maybe about 20 people show up to these kinds of events, and there's like thousands of clubs that you can kind of get involved with, and if the club doesn't exist, like you can just create your own club. Um, I'm also been in like anime club, but that's kind of just like for social events. Like sometimes they have like weekly showings of like an anime, or maybe they show a movie. Sometimes there's also game board nights for anime club, um, Super Smash Brothers. Sometimes they have like an open mic night, and I think like one of the topics was like what is anime, and we kind of just discussed had some controversies of like what anime is. Um, let's see, I was in Pokemon Club, but I didn't really like the experience there. I guess it wasn't my type of people. Um, but yeah, there's like social clubs like those, and there's like more competitive clubs. Like a lot of the clubs at Berkeley, you need to like apply, and you like they accept you, reject you, because it's like so much demand for a lot of things like that. Like it's kind of like applying to college. Like you have to like show why you want to be accepted to like a lot of stuff, like even clubs. But uh yeah, I'm not IEEE, CSUA, they accept anybody though, but I mean, um, I have like an activities officer role, so I'm a bit more involved in IEEE, and so that I guess that kind of looks a little bit better on like your resume that you're involved and you're like taking charge. Um, yeah, there's a lot. Like pioneers in engineering. I think they kind of accept anybody, but I'm not too into like the robotics part. So that's why I didn't like join pioneers in engineering. Funding crisis. So okay, CS at Berkeley, like number one top university. Everybody wants to go here. But at the same time, like I guess it's kind of ironic that we don't actually have enough money to kind of like hire TAs to kind of like keep the lights running, because there's like so many students interested in like CS. Like we can't support everybody. That's why we have the 3.3 GPA requirement, but we're still running into problems. Like I guess maybe 10 years ago, maybe there was maybe 400 people interested. I don't know the exact number, but now there's like 1,300 people like that are in EECS and CS like combined, and that's like a big number. And so that's why like even like some people that are like that were interested in CS, like they end up changing to a different major too. um or yeah, vice versa too. Like people that like me, I was molecular and cellular biology, now I'm switching to computer science. So it's like when you're admitted to the College of Letters and Science, you're undeclared no matter what, and there's like a bunch of majors like business, economics, applied. There's like at least 20, 30 majors that LMS offers. But since I was enrolled, like I'm enrolled in that college. Now I need to complete all the lower division requirements of the major before I can um like declare that major and say I'm doing this. And so that's kind of like the loophole that some people do, is like they like for me, like I applied to molecular and cellular biology, which isn't as competitive as CS. And so if I applied as CS, when I applied to Berkeley, I probably wouldn't have gotten in because CS is super competitive. But I applied as MCB, molecular and cellular biology, so it isn't as competitive, and that's, I guess I was lucky that I got in. That wasn't my intention though. I didn't like intend to change later on, but that's what happened. Um, so yeah, they're trying to kind of change because some people they pick an easy major like film or maybe like Spanish or Japanese or something like that that doesn't have like that much demand, and so that's why like they would accept them. But now like people like they're realizing, the college is realizing like these loopholes exist in like our system, and so now they're trying to kind of tighten up like the loose holes into like the system. So now they're trying to say you have to apply LNSCS. If you didn't apply on that in your application, you can't get in like to the major at all. That's what they're trying to do now. And I'm not able to play this video because of copyright, but definitely watch this video. Uh, but yeah, I'm just gonna show this one part. This is from the town hall meeting. I actually went to this town hall meeting. It was really interesting, but this is just a proposed idea. But yeah, I'll just explain briefly what they're trying to do. And they're trying to give only 270 slots for freshman applicants. That's like people kind of straight out going from high school to college, like straight to the 4 year. Is like we're only going to have 200 slots for people that just like are admitted directly to LNSCS. So it's like you put it on your application, you get in, like you're automatically declared. I think that's what they're trying to say. And you wouldn't have to worry about the GPA requirement. Whereas for the other 70, like let's say like me, I'm MCB, and I didn't realize I like computer science until um a little bit like after the fact, like 1 to 2 semesters later. And in that case, what's going to happen for fall 2023 and beyond is like there's going to be 70 slots where you can kind of like you're an LNS, but you're trying to change your major to CS. Like trying to get admitted to CS, and so you'll have to fill out an application where it's like a holistic and application process. Um, but yeah, like if you apply to LNS, they're trying to say like they can automatically just say like you can never do CS, but you can still go. You're still accepted into LNS, but you just can't do CS. Like that's one option, or they can straight out just reject you overall too. Um, so that's one possibility. Um, and like for the other 70, like it's not guaranteed. Um, like and so 50 slots are like for transfer students that are like straight out coming from community college, like transferring to Berkeley. So only about 50 slots for CS. Um, and so yeah, right now we have about 1,300 students that are in EECS and now in SCS, and they're trying to reduce it to 800 students. And this is just a tentative plan. Um, and so okay, alternatives to computer science major is data science. And so, the 3.3 GPA cap, because of this, like a lot of people, they switch over to data science. It has like this similar kind of requirements. Like you still have to take 61A, 61B. You don't have to take 70 like the math class, but you do have to take multivariable calculus and linear algebra, which I've actually done. But that's because like I was thinking about data science, but now I realize like let me try CS first and let's see how that goes. But yeah, data science is my backup. You should have a backup major, just in case like you don't get in if there's like a GPA requirement or something like that. But also a lot of people, they do like double major. Like I have a friend, or I guess an acquaintance, you can say, that they're doing both computer science and data science. But unfortunately I can't really do that because I kind of like switch later on. But I feel like a determined freshman, you have everything planned out. You can like definitely do like a double major, but you might just be busier overall because you're taking like more classes and like more major classes. So you will have like a heavier workload, and that's like a trade-off. Like you might not have enough time to like socialize. I mean, or you might have to give up on certain aspects of your life. Like yeah, like you'll have like more midterms. Like midterm season is going to be a bit more brutal for you, for example. Or maybe you could spread it out. Like you can take summer classes and it wouldn't be as stressful. Yeah. So yeah, a lot of overlap. And I guess at the end of the day, like your major doesn't matter that much. I guess it's just like when you're trying to get your first internship, you're applying to internships. It might be harder, but definitely like make connections with people, network with people, join clubs, and that will help you like get referrals and just help you overall. And once you kind of like get your first internship, and like then like companies realize, okay, this guy's experienced, and then at that point your major doesn't really matter that much. Like as long it's more about like the skills you've learned, grinding lead code. um yeah, so not declaring CS, not getting into CS isn't the end of the world. Like you can still do this, all right? But definitely give it a shot if you can. um yeah. And so this is a guide to declaring computer science that you can view on your own time. And like the lectures, like 61A, 61B, those are actually available like publicly, I believe. Um, so you could just take a look if you want to look at the lectures. These are a couple of memes that I like these memes. If you have time, check these out. And this is my GitHub, um, my LinkedIn. Yeah, definitely check that out. And question and answer, I'm trying to think of what people asked me during the presentation, but if you guys have cute questions you want, you can drop a comment and I'll try to respond. And yeah, thank you for watching.